Okay, got a lot of naming to do, so let's get started. We have 3-methyl-2-pentene. This 2 indicates the position of the double bond. So first it's pent, so it's based off of pentane, so draw a pentane. The double bond makes it unsaturated, and so we have to draw that in, put that in, and where? It's 2, that's where it begins, so it's 1, 2, right there. And so every double bond has 2 positions. In this case it'd be 2 and 3. That 2 indicates the position of the double bond closest to one of the ends. So here's the 2, or here's the double bond. It's closest to this end, 1, 2. So we have everything there. And the other carbon is the 3, and that's where the methyl group goes. So pretty easy from the name to the structure as usual. The structure to the name we have to be a little more careful. Find the parent chain first. The parent chain has to contain the double bond. So here's the double bond, and then we start numbering from the side closest to the double bond. In this case, that double bond is right at the beginning. I was going to say the end, but it's at the beginning. Like that. It is butene, or 1-butene. There's a methyl group at the 3rd position. So 1-butene. 3-methyl, 1-butene. So actually the naming is easier because we only have to focus on the double bond. We don't have to worry about the substituents until after we've determined which side begins the chain. So this thing could be bristling with functional groups, or with substituents, but it's that one functional group, our new one, the double bond, that determines the numbering. So this one it's not too bad, but the larger molecules, it really helps out. So I should also mention that there's another way of naming this that is still IUPAC naming. Whoops. There's 3-methyl. You can see that I'm not used to naming it this way, but this comes up in the more advanced organic textbooks. So it's 3-methyl-but-1-ene, where they put the number right in the middle of the butene, and right next to the functional group, or the name, that part of the name that indicates the functional group. We're not going to use this. I just want to let you know that it exists, and you can see that it's not that bad and that much of a difference, but if you go on to a more advanced organic course, you have to see what your textbook and what your instructor want you to do, but we're going to stick with our this form of labeling. Then we have 1,1-difluoro-4-methyl-heptene. So 1, 2, 3, 4, 5, 6, 7. That's heptane. 1, 2, 3. That's where the double bond begins at the 3rd. Goes from the 3 to the 4 carbon. We started numbering from this side, so put 2 fluorines on here. And then 1, 2, 3, 4. 1 methyl. Now, if this had been 4,4-dimethyl, we know that there was a mistake, because you can see this carbon has 1, 2, 3, 4 bonds to it. We can't put any more. So if we saw 4,4,4-trimethyl, we know there's a big problem, because then we'd have that'd be 6 bonds to it. So the name can appear to be a real name, and you can even draw it when you're done. If this was 4,4-dimethyl, we'd just put another methyl group here. But then you look at it, you can see that the name is for a nonsensical molecule, which causes some trouble when I'm writing these up. Sometimes I create the name on the fly, and then I had to go back and I realized, whoops, that doesn't actually exist. So for this one, so I always double check everything, but if you see that in the book or on the exam, you'd want to let me know. So we have 1, 2, 3, 4, 5, 6, 7. That's the longest chain. The double bond is closest to this end. So you see how nice the numbering is. We don't have to consult with anything else. We don't have to look at the substituents at all. We just look at that double bond that tells us the numbering. And then we call this, now we name it as usual. We have an ethyl group, so we call it 5-ethyl. There are 1, 2, 3 methyl groups. So 5, 6, 6 tri-methyl. And then it is, the double bond begins at 2. Remember, it's going to cover 2 carbons. That's how you make a double bond, but there's we go with the lowest number, so 2. And then what did I say, heptene? Heptene. And of course that would end with trimethyl-hept-2-ene if you wanted to do it by the other naming. And if that's how you learned it in some previous course, feel free to use that. But if you've never seen this type of naming before, I'd stick with the way that I'm normally going to do it, just to get used to it. So nonene, 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm going to label it from this side, number it from this side, because we have all of these big groups and they'd get lost in the letters up here. So I'll start from this side. So this is 1 nonene, so the double bond is at position 1, and then we have 5 ethyl groups. So 1, 2, 3. We have an ethyl group here, an ethyl group here. 1 at 4, 2 at 5. And then 6, 7, and then an iodine at 7. So 1, 2, 3, 4, 5, 6, 7, 8, 9. It looks like everything's there. And then 1, 2, 3, 3, 4, 5, 5. Yeah, it looks good. Okay, for this one, we have to determine the position of the double bond. I put dots on all the carbons just so, because we have all of these we got these halogens hanging around. They look like they extend the chain, but this is where the carbon ends, and the carbon chain ends, the parent chain. So from this side we have 1, 2, 3. From this side, 1, 2, 3. So either side gives us a 3 for the start of the double bond, so that's fine. So then we go on to the substituents. We see we have chlorines on the first carbon here, so that's going to be our start. So we'll label. I'll put the numbers in here. So that double bond doesn't tell us everything. It's going to be 3 either way, so we have to go on to, just like we've done before, when kind of a tie, then we go on to the next indicator, which would be which end has the, where do you first meet up with the substituents, and on this end they're right on the first carbon. So this would be, but we have to go alphabetical order, 5 bromo, 1, 1, 1 trichloro, 3, what did I say, 6? Hexene. Make sure it's E-N-E. At this point, people get it perfectly right, and then they'll call it 3-hexane. So make sure that, and I have to mark you down, this is ene, this is a double bond. And since I'm saying that, let me go back and verify that I did use ene. Yep. Okay, then for everything, then we have pentene here. 1, 2, 3, 4, 5, 2, 1, 2. We'll just put the double bond here. You could have started numbering from this side if you want, but once we've set this up in this form, then we have to start the numbering from this side because we've placed the double bond, and then this is chloro, boom, boom. So you see, I'm moving faster, but you know that you should know the basic naming, and all we did was add in one little extra feature of the double bond. So I'm going to put and you don't have to do this like I'm doing, where I put a little circle on all the carbons. I'm just going to do this the same way each time. And you notice I'm not numbering as much either. I assume that you have a pretty good idea of how to number them once you've found that double bond. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Decane becomes decene. It's at site, and this one I'm going to number them just because there's so much going on here. And you can see that the double bond starts at 3, so we start from this end. We have a chloro, fluoro, ethyl, 2 methyls, so chloro comes first. This is 2 chloro. Then the ethyl group, alphabetically, the number is higher, but the ethyl still has to come first. There's only 1 ethyl. Then 3 fluoro. What else do we have? Methyl groups. 8 dimethyl. 3 decene, if I can squeeze it in here. Yeah. Wow. So really, there's not that many substituents. It's just that they're all different, so each one gets their own little segment of the name. I think that everybody's there. And then 1,2-dimethyl cyclopropane. Well, that should be propene. I'm not even sure if this was supposed to be on here. It might have been left over from a previous lecture when I just cut and pasted, but let's make it into something. Now we're into the cycloalkenes. So that's cyclopropane, that's cyclopropene, and no numbers. There's no number because this is 1 and this is 2, or this is 1 and this is 2. As we've written it right now, it doesn't matter. And but if we choose this to be 1, this 2, then this is methyl. Actually, it turns out it doesn't matter. either way because they're both the same group. But we'll see that the numbering will matter later on. But for one of the rule for cycloalkenes is that the double bond, if there's only one, the double bond has numberings of 1 and 2, and we have no choice in that. So let's take a look at this next guy. Let me make sure it was on there. Let's look at this next guy. So we have this guy here. I'm going to expand it out because there's a lot of different things that can happen here. Now, you might say, well, there's the ethyl group, so we'll call that 1. If there's no double bond here, if this was a cyclobutane, then that would be 1. But we know the rule is 1 and 2 have to be on this double bond. We have no choice in that. So you might think, well, we'll put that 1 there. Oh, we'll sneak a 2 over here. No, can't do that because the 2 has to be on the other bond. And we want that so that we don't have to number that double bond each time. We can leave the number off for that. When there's one double bond in a cyclic alkene, we don't have to put the number for the double bond because we know what they are. So if we pick this to be 1, then this is 2, then this is 3, and then this is 4. Now, once we've picked that, then we have to see what we've done with the numbering here. We have a 3 for methyl, 4 for ethyl. Well, if we made this 1, then this 2, then this would be 3, and this would be 4. Now the 3 is for ethyl, 4 for methyl. That's the way that we want to go. So we know that the 1 and 2 have to be on the double bond, but then we want to label them in a way that will give us the lower numbers for the substituents. And in this case, we want the 3 to be for ethyl. So we're stuck with 1, 2 or 1, 2. So either this way or this way, but then we have to determine how does that affect the numbering for the substituents. So this is the best way to do it to get the lowest numbers. So it's 3 ethyl, 4 methyl, cyclo, got to put that cyclo in there, butene, and have to have that ene. Sorry about the going kind of up there, curving up. But it's 3 ethyl, 4 methyl, cyclo, butene. No need to put a number in here. The only number you could put is 4-methyl-1 cyclobutene. We'd always have a 1 there. That's why we leave it off, because it's always going to be a 1 when there's only one double bond. We'll talk about multiple double bonds in a second here. 1,5-dibromocyclopentene. So put it here. Put the double bond. We have the bromo. 1, 2, 3, 4, 5. And it looks like, so wait a minute. If we made this 1, 2, 3, then we have 2, 3 dibromo. But the 1 in this case, there's two things going on. First, the 1 has to be on one of these carbons, but in the double bond. But there's also a bromine here, so this one wins out. It has to be the 1 because not only is it a double bond, but it also has a substituent attached to it. It has a bromo group on it. So it does look like you could put a 1 here, but the numbering would be lower. But whenever there's a substituent attached to the double bond and there's none on the other, the one that has the that substituent is going to be site 1. So there's you got to be a little bit careful. And I know I went through that took a long time. You might have to go back through that, or ask. You can check the book. The rules are definitely in there, or email me. But it's a case of precedence here. Which one will get which? We know that the carbons are going to be 1 and 2, but which one is going to be 1? It's the one that has a substituent on it. For this guy, this one we just call fluorocyclopentene. Looks like we're missing something, but this is why this kind of goes along with the last one. We know that this fluorine is going to be on 1. This is not going to be. We're not going to call this carbon 1 and this 2. So we say fluorocyclopentane. We know that because of the precedence that of that substituent and the double bond. We know that this is going to be of these two carbons. There's going to be a 1 and 2 placed here, but because there is a substituent on this one, it has to be the 1. And so, since that's going to be 1 anyway, there's no reason to put 1 fluorocyclopentene. And if you put 2 fluorocyclopentene, you could certainly come back to this structure, but it'd be the wrong name. 6 bromo, 1 chloro, 1,4-cyclohexadiene. See that diene there? It means there's 2 double bonds. One begins at 1, one begins at 4. So cyclohex. Oh, that's just great. I swear I can do this better. I just this angle is quite tricky. So we have 1, 2, 3, 4. So 1, 2, 3, 4. That's 1,4-cyclohexadiene. Then we start labeling. We have a 6 well, let's do 1 chloro. 1, chlorine is there. 2, 3, 4, 5, 6. That's lovely. Bromo goes there at site 6. So this is 1, 2, 3, 4, 5, 6. Been doing a lot of these today, getting a little loopy. So the reason this is 1 is because there's a chlorine attached to a carbon that also has a double bond. This is 4 because it's the, so 1, since this has to be 1, we have to go in this direction. You could say, well, if we made this 1 and 2, 3, 4, it'd be the same thing. But we have to go in this direction. This has to be carbon 1. We have no choice there. And the more, you might not see it. Sometimes it's trickier to see. Just work out a few of these. Look at the book, and if you don't get it, that's when you want to talk to me. We can do out lots of different examples when we meet up or by email. Okay, so we have this one here. There's no substituents here, so if we can label it either starting. You see, it's very symmetrical, so we could start here, 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 or here. But you can see that these two will be the same as these two. So it's either here or here. If we start here, then it's 1, 2, 3, 4, 5. So it'd be 1, 5, or 1, 2, 3. So it'd be 1, 2, 3 would give us the lowest numbers for our double bond. So this would be 1, 3, cyclopentadiene. And if there was enough room, we can't, well, I guess we could do it for this one, but you can also have trienes as well. But normally we don't have enough room for that. Maybe for cyclooctanes we might. I also want to point out that this can be named using those other rules. And you can certainly fast forward over this if you don't want to see anything about this. I just want to mention it because cyclohexa-1,3-diene is another way of, another IUPAC type of naming that we can do. Just want you to be aware that it exists, because if you go into another textbook or you go online for some help and you might see something like this and just wonder why I'm lying to you. And I'm not. There's just another way of doing the naming. All right, for this guy, this has to be the 1 position, 2, 3, 4. So we call this 1 chloro. And this has to be the 1 position because it has the only substituent here. So that is, not only is it part of the double bond, but it has a chloro group on that. That's big. So it wins out. And then we number appropriately. 1 chloro, 1, 3 cyclopentadiene. Cyclo has to be in there. The diene has to be in there because there's 2 double bonds. And then this last monster, well, this has to be 1 again. And you might say, oh, there's a substituent here, another methyl group. We'll call that 2. Once we've made this carbon 1, this has to be 2. And then we go right around. So on the ring, same thing. That double bond locks the numbers into place. Once we're all set, we have to go, this is 1, this has to be 2. And this is 1 because we have a methyl group off of it. There's no methyl group over here. So this thing would be called 1, it's on the page, 1,8-dimethyl. So this is about as tricky as it gets. 1,5-cyclooctadiene. There you go.